When you are doing Igcse Edexcel physics, there is a topic that you have to do also, that is refraction, light, and waves. So today we are going to look into this topic with the question that you possibly can be asked and how you are supposed to approach each of the concept that is tested there. The first part that we're given here is a question, and we're supposed to state what is meant by the term refraction. We're going to say that refraction is actually the bending of a wave at the boundary as it moves from one optical medium to another. When light moves from one medium to another, light slows down, and in the process it bends towards the normal. We are also given a diagram, and then we are supposed to draw the path of ray of light in the water. The torch is directed at an angle of 45 degrees. So what is going to happen here? You're going to realize that as the ray of light moves from air into water, water is dense. So the ray of light is going to slow down the moment it strikes the boundary, and then it's going to bend towards the normal. So that when we are going to have our diagram here, we're going to draw this ray of light such that it bends towards the normal, and then we have the angle of refraction down here. We are told that to state the formula linking refractive index, angle of incidence, and the angle of refraction. Refractive index is the one that determines how much the ray of light is going to bend. The larger the refractive index, the more the ray of light is going to bend towards the normal. And the formula that we are going to use to write refractive index, remember, we are going to say that refractive index equals to the sine of angle of incidence divided by the sine of the angle of refraction. This formula can be written as n equals to sine I over sine r. I think this is very, very common, and this is very familiar to you. So as you're preparing for your exams, this is an area that you need to focus. Show that the refractive index of water is about 1.3. Remember, refractive index is a ratio, so it doesn't have units. So when you are told to determine the refractive index or to show that it's 1.3, this question is asking you to try to work out the refractive index using the information that is provided in order to come to a point you have it 1.3. So let us go ahead and try to work it out. Remember, we know that refractive index equals to sine I over sine r, and in our case sine I or I, angle of incidence, is 45 degrees, and the angle of refraction here is that 3 degrees, because that is, it was given on the diagram below here, the one that I've circled. Then if we work out this, we are going to get our answer as follows. You just make sure you are using your calculator properly in order to get the correct answer. So we have 1.31, and this is approximately 1.3, the one that we were supposed to show. The torch is moved below the surface of the water. Light from the torch is incident to the water surface at an angle greater than the critical angle. So if the torch is moved from its position and it's now directed from the water surface upwards, it means the ray of light will be moving from a dense medium to a less dense medium. And that's one of the conditions of total internal reflection. And if you look at this question, we are told that the angle of incidence in water is greater than the critical angle. So it means total internal reflection is going to occur at this particular point. But let us look at Roman 1. It says, explain the meaning of the term critical angle. Critical angle is a special angle, is a type of angle when is a type of angle of incidence in the dense medium, when the angle of refraction in the less dense medium is 90 degrees. So let us write it down so that you can get to understand what I'm saying. Critical angle is the angle of incidence in the dense medium when the angle of refraction in the less dense medium is 90 degrees. So if you are given such a question, and that is what you are expected to write, and I can see here they said you may draw a diagram to help you answer. Of course, sometimes this diagram cannot award you a mark unless and otherwise the examiner is fair enough, but it simplifies your explanation. So let us see, which diagram were you expected to draw? We can have a diagram like this, and the ray is moving from a dense medium to a less dense medium. So the angle at the top here is 90 degrees. So this is a less dense medium at the top and dense medium below. So since this ray is moving from a dense medium to less dense medium, then there is a point we have an angle of incidence in the dense medium when the angle of refraction is 90. So when you have angle of refraction in the less dense medium equal to 90, then the angle that is in the dense medium has a special name, and that special name is critical angle. Next, state the formula linking critical angle and the refractive index. So that is going to be sine of the critical angle equals to 1 over the refractive index. So this is very critical. We can use it in order to, maybe if you are given the refractive index, like in this question, you can be able to use that formula in order to come up with the critical angle. So we're going to, in order to find critical angle, we're going to find the sine inverse of 1 over the refractive index, and if you put that, you're going to get our answer as 50. Just let's use the calculator and check whether that's true. So the answer is 50.3 degrees. So we know the critical angle is 50 degrees. That is 50.3 degrees. The critical angle is very important because it enables us to know whether total internal reflection will take place or not. Now, when this ray of light is moving from water to air, when the angle of incidence, for instance, in this case here, we have 55 as the angle of incidence. So if this angle of incidence is 55 and it's more than the critical angle, then it means in that kind of scenario, refraction will not take place, but total internal reflection will occur. So complete the path of the ray of light. In order to complete this, you need to have that knowledge that I mentioned, that you have to compare. And most of the time this question is given when you have calculated critical angle, or when the critical angle is given, and then you have this type of question below asking you to draw the path. They are trying to check, do you really understand what is the meaning of critical angle and where does it help? So if you check here, our critical angle was 50.3, but the angle of incidence now here is 55. It means if this ray is directed to the boundary like that, it's not going to undergo refraction, but total internal reflection is going to take place, and this is then what we are going to have. So you see, conditions for total internal reflection are the angle of incidence should be greater than the critical angle. That's one of the conditions. And the second condition is the ray must be traveling from a dense medium to a less dense medium, which is the case. It's moving from water to air. So the two conditions are satisfied. And so this angle is greater than this one. 55 is greater than 50.5. So which means that in our case here, we're going to have total internal reflection, and then the angle that is going to run, the ray is going to move at an angle of 55 degrees like that. So this ray is going to be traveling in this 55 degrees in that particular direction. So that is how the ray of light is going to behave. Moving further, moving on, and if you are new to this channel, consider subscribing. Give this video a thumbs up. If you really benefited from this tutorial, you can leave a comment down below, just as a form of appreciation. You can also share this material or this particular tutorial to your friends who can also benefit from the same. Back to the main agenda of this video, we need to go down and look at this question. Here also you are supposed to define and state the term critical angle, and we already say that is the angle of incidence in the dense medium when the angle of refraction in the less dense medium is 90 degrees. And you can even draw a diagram, maybe a diagram using a semicircular glass block. If a ray is directed like that, you see it's directed in such a way that it's moving from glass. You see, at the point where this ray is meeting the circular glass, the curved part of the glass, the ray does not undergo any refraction because it meets the glass at 90 degrees. It's meet at that particular curve where that ray meets with the semicircular part of the glass. It's 90 degrees. So it goes straight into the glass without being refracted, and it hits where we have the normal at the central point. Then the ray is going to move along the flat surface such that it forms 90 degrees. So the angle that we have down here, the angle that we have here is called a critical angle when the angle at the top is 90 degrees. So this is another particular diagram you can be able to draw if asked. The diagram shows a cross-section through one of the binoculars. There are two glass prisms inside this half of the pair of binoculars. Complete the path of the ray as it travels through this half of pair of binoculars to the eye. Remember, the critical angle of glass is 42 degrees. So something that I need to remind you, this semicircular prism has got 45. So the moment the ray enters the glass through the flat surface, it meets it at 90 degrees, so it does not undergo any type of refraction. But the moment the ray goes straight to this particular end, it will be reflected such that it changes direction of 90 degrees. Yes, and this happened because the rays of light in the prisms undergoes total internal reflections. Because those angles of incidence are 45 degrees, which are more than the critical angle, then total internal reflection is going to take place. And most of the time you find the images formed by such kind of prisms are very clear because no energy of light is lost. I believe we are together up to that particular point, and the reflection took place, is total internal reflection, and then we can now move to the next part. We are told that name 2 additional pieces of instrument or equipment the student need for this particular experiment. The student wanted to study what? Refraction. The student wanted to study refraction. So instrument that are required for refraction are the glass block. We have a pencil there. Now we need also a protractor, and the protractor's purpose is to measure the angles, and we need also a ray box. A ray box will be acting as a source of light. The diagram shows the path of a ray of light as it travels towards and through the glass block. Draw the path of the ray of light when it leaves the glass block. Now let us move down and try to see. This is how the diagram looks like. So the first thing that you need to identify, or you need to do when you're given that kind of question, you need to draw the normals. So we need the normals at that particular point, and then we are going now to draw the ray of light at that particular point. Moving further, determine the angle of incidence and the angle of refraction at the point where the ray of light enters the glass block. So at this particular point, you are going to use the protractor to measure those angles, and this is how you are going to position. This is how you are going to position your protractor. Angle of incidence is the angle between the normal and the incident ray. So at that particular point, if you look at it keenly, this angle is 43 degrees. 43 degrees. So we need also to measure the angle of refraction. We shall shift it and adjust our protractor like that, and try to measure the angle formed here. Let's see that angle. Let's check that angle. What is it? That angle is 25 degrees. Angle formed between the ray and the normal that is drawn there. State the formula linking refractive index, angle of incidence, and the angle of refraction. In this case, we are going to write that because this is not the first time we are mentioning this. This is what we expect, and we're going to use that formula in order to work out the refractive index, substituting exactly what you are able to measure above. Don't use other values. Use the values that you got from the protractor when you did the reading. If you use different values, you are going to lose marks here. So this is going to reduce to, if we put this in a calculator, we're going to get 1.614, which is approximately 1.6. And remember, refractive index does not have units because this is a ratio. A teacher suggests that more accurate value of the refractive index can be found using graphical method. This method that we have used above here that has given us 1.6, we have just made use of two angles, 43 and 25. So chances are there could be errors, and that's just one point that you have used. So if you want to get a more accurate value, you need to do more measurements. You measure more angles of incidence, and then you measure corresponding angles of refraction. So you see, when you have more angles, accuracy is going to be guaranteed. Design a method to obtain a value of the refractive index of the glass block using the graph. Then you may draw a diagram to support your answer. Now let us go straight ahead and try to respond to this question. So given a question, what are you supposed to do? You should write using different angles of incidence, measure corresponding angles of refraction. So here what we are saying is you are going to direct a ray of light to the normal of the glass block, and then you shall measure different angles of incidence, and then you check what are the angles of refraction at those particular angles of incidence. Then this is exactly what you're going to do. Next step is plot a graph of sine I against sine R. Now after you have gotten pair of angles of incidence and angles of refraction, you are going to find sine I, you are going to find sine R in a table, and then you shall plot a graph of sine I against sine R. Then you see here we are going to get a straight line graph. This straight line graph indicates that as the angle of incidence increases, the angle of refraction also increases. Then there are some other things that we can be able to use this graph for. We can use this graph in order to find the refractive index that we had worked up there. So when you are using a graph to find the refractive index, you are going to work out the gradient of this line. And the gradient from here you can see is rise over run. Rise is sine I, run is sine R, then this is equal to the refractive index. This particular method is a bit accurate compared to just using one point. This method is more accurate because it involves many values, and also you can be able to identify anomalous points. Anomalous points are those values or those points or those readings you find, they are inconsistent with the rest, they are much above the rest. So if you are able to take many readings for this particular method, and then you identify there is one reading that is so big or so huge, it means that's an anomalous point, and then you are going to draw a line of best fit. So sometimes the reason as to why I mentioned this, in this particular question you were not supposed to have mentioned it, but what I'm saying is that sometimes you'll find questions asking you, why is this method accurate? It's because it involves more values, and at the same time you can be able to identify anomalous points which you can disregard in the process. Because when you have anomalous points, the way you deal with it is that you can repeat that point that is anomalous and see where the error was, or you can assume. And let me mention this because this is a question that also most of the time comes. When you are given a table of values and there is anomalous point, when you are told to work out the mean, don't use the anomalous point. Disregard it or ignore it. I believe that point is home. So we can be able to move to something else. This was not part of the question, so that's why I'm removing it. So the remaining part is what you are supposed to have answered. So we have a ray of light traveling all through medium here, and then we are told that when a very bright light shines on the transparent material, a small amount of light is reflected at point X. So you are supposed to draw the reflected ray from point X, and this is exactly what you are supposed to do. Now, diagram 1 shows what happens when light is incident on a piece of transparent material. We have a ray of light moving into point X. It goes through Y, Z, and then it is refracted on the other end, and then it emerges out of the transparent material. Roman 1, we are supposed to draw how the reflected ray will go from point X. And this is exactly what you will have. Measure the angle of refraction at point X. Measure the angle of refraction at point X. We're going to use a protractor. That's why during exams, physics exams, you must have your protractor, even if you are not told. Adjusting it properly, putting it there. Then if we measure the angle, let us zoom it a little bit so we see where that mark is. We check that is 32 degrees. Very good. Now, angle of refraction, 32 degrees. State the formula linking refractive index, angle of incidence, and angle of refraction. Just a walk in the park. This is a very, very good question. We've answered this before, so this is what we have to write. Next, show that the refractive index is about 1.7, meaning we are just going to work out the refractive index and check, is our answer 1.7? Let's see. Sine I over sine R, this gives us 1.69. If you round off, this becomes 1.7. State the formula linking refractive index and critical angle, and this is going to be sine of critical angle equals to 1 over n. And then in order to work out the critical angle, we are going to use the above formula that we have mentioned, and then we are going to say 1 over the critical or the refractive index, which is 1 over 1.7. And in order to find C, we are going to find the sine inverse of 1 over 1.7, and this is going to approximately be, use your calculator and check. What's your answer? Yes, 36 degrees is the critical angle. Explain the behavior of the light at point Y and Z. You can see at point Y and Z here, at point Y and Z here, this point here. What are you noticing there? Y and Z. Is the ray of light emerging out of the glass? No. So that means what? Total internal reflection is taking place. And for total internal reflection to take place, the ray must be traveling from dense medium to less dense medium. So if the ray was moving from X to Y, that is in the dense medium. But if it was to get out of Y towards the lower part, that's a less dense medium. So meaning here total internal reflection has occurred because the angle of incidence in the dense medium is greater than the critical angle. So no refraction took place. So what happens? This behavior is light has undergone what we call total internal reflection. Since the angle of incidence in the is greater than the critical angle, and the ray of light is moving from a dense medium to less dense medium. That's what you are supposed to respond at that point. Have you benefited from this tutorial? If you've benefited, leave a comment down below. Give this video a thumbs up, and also you can be able to subscribe. Conditions for total internal reflection: critical angle must be greater than the angle of incidence must be greater than the critical angle, and also the ray must be moving from a dense to less dense medium. Diagram 1 shows a light ray entering the glass prism. Now you see, we are given an angle of 40 degrees there, but that angle is not between the ray and the normal. So we have to find that angle there. Describe what happens to the ray of light when it enters the prism at point A. Look at point A. The ray is moving from air into the glass prism, meaning it's moving from a less dense material to a dense medium, which means that this ray is going to slow down. The speed of light is going to slow down, and then the ray bends towards the normal. That's why refraction takes place. Light slows down and bends towards the normal. And the reason is it's moving from a less dense medium to a dense medium. So you realize that if a ray is moving from a more dense medium to a less dense medium, it will bend away from the normal. But if it's moving from less dense towards towards the more dense medium, it will bend towards the normal. Like this one you see now, the angle of incidence outside is less than the angle that we have inside here. So the ray bends towards the normal there. State the name of the line XY. XY is the normal, the diagram that we are having at the top there. And we are supposed to state that formula already. We have mentioned that before. How to work it out, that's self-explanatory because we have done it before. That was 38.68. So if you round it up, you're going to get 29 degrees. Complete diagram 1 by continuing the path of light travel from point B. Now let's look at point B, but have it in mind that the critical angle is 90, or rather the critical angle is 39 degrees. You need to have that in mind. If the angle of incidence is more than 39, then total internal reflection will take place. But if it's not, refraction will occur. Let's go back to B. 39 degrees, this is our critical angle. So let's go back to the diagram. You can see now our XY is the normal. So at B, which angle are we having here? 90 minus 40, give me the answer, 50 degrees. So is this 50 degrees more than the critical angle? Yes. So if it's more than the critical angle, it means that total internal reflection will take place. 50 is more than the critical angle, which is down here. So going back to the diagram, this ray will travel like that, making 50 degrees, which means total internal reflection will take place. Our ray, when it gets out of the glass prism on this other end, it will move like that. It will bend away from the normal. But our normal is there, so it bends away from the normal like that. But this question was really focusing only at this particular region B. This is where if you didn't draw the other side, it doesn't matter. But the question was testing whether total internal reflection will take place or refraction will occur as well. The critical angle of the material of this prism is 55 degrees. Complete diagram 2 by continuing the path of the ray of light. Now, the angle of incidence now in this case is again 50, because 40 minus 90 minus 50, rather, what am I saying? 90 minus 40, it will be 50. But there is this information we are provided. The critical angle is 55 degrees. And the angle of incidence in the dense medium is 50. You can see the angle of incidence is less than the critical angle. So it means in this now kind of scenario, total internal reflection will not take place. What will occur is refraction at that particular point, and that is the refracted ray, and this is R is the angle of refraction. So basically that's what you are supposed to draw to complete the ray. We are supposed to draw the normal where it's incident, the ray of light strikes the flat surface of the glass block. So the normal, we are going to draw it like that there. Some light from the incident ray passes into the glass block and it's refracted. So let us draw how is refraction going to take place. But remember, refraction is the bending of a wave. And now since the ray is moving from less medium to dense medium, which is glass, this ray is going to bend towards the normal like that. This is the refracted ray. Roman 3, we are told some light from the incident ray is reflected at the boundary. Draw the reflected ray of light. Let's check. Yes, it will travel like that, and that's the angle of reflection, and this is the reflected ray, and here this is the angle of reflection, and below here is the angle of refraction. Part B, a student investigates the refraction of light by the semicircular glass block using equipment in the photograph. Some of the equipment we have here, we have the glass block, semicircular glass block. We have a protractor. We have a pencil. We also have a ruler. And remember, the other requirement that we need is a ray box. We need a ray box which will act as a source of light, but it's not here. We know that the ray box is going to act as the source of light. Glass block is going to refract light. Protractor is going to be used to measure angles, and the ruler is going to be used to draw straight lines. Design an experiment to investigate how the angle of incidence of a ray of light affect the angle of refraction in the glass block. You may draw a diagram to help your answer. Now, in order to respond to this particular question, these are the following key aspect that you are mentioned: trace an outline of a semicircular glass block, and you are going to do that on a piece of paper. Then you are going to direct a ray of light from the ray box, and then you are going to measure angles of incidence, and then mark how the ray is going to get out. So direct a ray of light from the ray box to the glass block, and use a protractor to measure the angle of incidence. Mark where the ray of light exits the glass block, and then use a ruler to draw the refracted ray. Once you've done that, measure the angles of refraction, and then now, using different angles of incidence, measure more corresponding angles of refraction. Then we're going now to fill a table and then plot a graph of sin I against sin R. If you draw this graph, you're going to get a straight line graph. And I've already mentioned that in previous sections, that if you have this kind of graph, you can see that the sine of I and the sine of R increases like that. So it means as you increase the angle of incidence, the angle of refraction also increases. With this type of graph also, you can be able to work out the gradient, and the gradient of this graph or provides or correspond, or the gradient represents the refractive index of the material. As I've mentioned, this method is more accurate when determining the refractive index because it involves many values, and also if there are errors, you can be able to identify anomalous points.